Welcome to the 8th video of the Java Basics series, where we'll learn how to make it so that we can automatically create an object with predetermined data instead of having to manually set the fields of the object every time, as well as making data private so that we can control access to it with our own methods. So firstly, let's go back and look at our code from the last video to initialize each of these video game characters. So here you can see we just create the video game character object and then manually assign it name, health, and a weapon. So it takes around 4 lines of code here to initialize and create every single video game character object. So what we want to do ultimately is make this process of creating a video game character much shorter. And hopefully we can create a character object all in one line. So that's exactly what constructors allow us to do. They let us initialize an object with predetermined data, meaning we don't have to set all the object's information inside of our main method after creating the object itself. We can create the object with our data already in place. So firstly, let's copy this lesson 7 code over to a new lesson 8 code file, and then put all of our lesson 7 code into it so we can make changes from this existing code here. So now what we want to do is make a constructor for this video game character which automatically assigns the character's name, health, and weapon. So in order to do that, a constructor is built very similarly to a method, except there is no data type, not even void here. So it'll be public and then no data type, and then the name of the constructor has to be the same as the class. So video game character is the name of the constructor, and it matches the class name here. And the reason why these class names and the constructor names have to match is because when we create our video game character objects now, we'll be putting all the data we want to initialize the character with in these parentheses here. So it can basically be thought of as a method, but it actually creates the object itself. So you need new here so that it creates a new object. And so we want to initialize the character with a string name, health, and a weapon. So now what we want to do is we want to assign the name to this video game character's name, the value of this name that's being passed in, and same thing with health and weapon. And so if we were to access name, you can see that name actually refers to this name here that's being passed in. And so in order to access the name that's part of the video game character object, we have to use a special keyword called this. So this refers to the current instance of the character, the current object that we're dealing with here. So it would be player 1 in this case and player 2 over here. So this is just a much more convenient way of accessing the object itself. So now we have to access the video game character's name and then set it equal to the name the user provided. And then we can do the same thing with this .health and this .weapon. So this allows us to access the object, and so it's important when we have parameters with the exact same name, so we can still access the data that the specific object has. So now if we go back to our main code here in our main method, you can see if we were to type in video game character again, it now has all these parameters that we have to fill in. So now, because the constructor automatically sets these name, health, and weapon, we can just pass them inside the parentheses in our constructor here. So the name can be Bob, health 100, and then weapon sword. And then do the same thing with player 2. So name can be David, health 90, and weapon staff. So now you can see if we run the code, it works exactly the same way. It's just that the way we're initializing these objects is now more convenient and more simplified. Instead of having to initialize the object and then assign the data to it, we can initialize the object with the data already in place. So that makes for a much more convenient experience when working with dozens of different objects. So now we've got all of our creations of characters to fit inside a single line, but there is one flaw with our video game character system here. So we can still change the health, name, and weapon using the dot here to access the player's data. So that means we can set, for example, the player's health to an invalid value like a negative number. And then that's what would print out inside the console, which is obviously not correct. So we have to find a way to prevent assignment of invalid values. So in this example, we shouldn't be able to assign negative numbers for the player's health. So this problem is where our next concept, encapsulation, comes in. So encapsulation involves hiding an object's internal data and only providing controlled access to it through our own custom methods that we make that allow us to get values and set values. And those getters and setters we can customize so that they can't get or set invalid values or do things that we don't want to do. So now let's actually incorporate encapsulation into our class. So firstly, our main problem here is that the player's health can be accessed, and all of these properties, for that matter, can be accessed just by other files in the code base. So what we can do is, before the data types of each of these fields, add the private keyword. And the private keyword makes it so that these variables can only, or these fields of data can only be accessed inside of this class and not in other locations. But we still need access to the player's health. So what we can do is we can create a getter method for it. And so what we can do is type GET, and you can see that the auto completion here comes up with sample methods for getting the health. So we can click on it and it'll create a basic get health method, which will just return the player's health. And so now we can do the same thing with set health. And then we can create getters and setters for the rest of the fields here, like the name and the weapon. And so now you can see these fields themselves are private, but we can change them making use of these getters and setters. And the benefit of using the getters and setters is that we can control what actually gets returned back and the data that's actually changed. And so the problem with our current set health method here is that the user could still give a negative number and it would change the health to be negative. And so what we want to do is prevent health from being set to a negative number. So in order to do that, we could make use of an if statement or an if-else statement. And so now we have to check if the health the user provides is not negative or is at least equal to 0 or higher, and only then we can change the character's health. But otherwise, we can print out a message saying negative health is not allowed. And so now we can change each of these fields that we access in these print statements to the getters that we created. So now you can see the benefits of using getters and setters in action. They allow us to control the data that's injected into the object and the data that the user can actually access. So if we want to protect access to the weapon, then we can just remove these setters and getters for the weapon and not include them at all. And so now it'll say the method getWeapon is undefined and the weapon field is also private, meaning we can't access the character's weapon anymore. So even if you're not using getters and setters, using the private keyword is a good idea if you just want to completely disallow access to a specific field. So getters allow us to get fields but not directly change them, and setters let us change the fields but under specific rules that we make so that the user can't just randomly change them. So now let's go over the homework challenge for episode 8. So what you want to do is take that smartphone class that we built earlier for the previous episode 7 challenge, and what you want to do is extend it by firstly building a constructor that allows the phone to be directly initialized with its fields of information, the brand, model, and battery life. And you also want to set these fields to private when you create the brand, model, and battery life at the top of the class, and then create a setter for battery life that adds a constraint so that the battery life has to be between 0 and 100. And you also want to test it in the main method when you actually create the phone by providing some valid and invalid values to make sure it actually works properly. Thank you very much for watching. Like and subscribe if you enjoyed the video. And look out for episode 9, where we'll go over 2 new concepts regarding object-oriented programming: inheritance and polymorphism.